today in his talk on Brown County State Park from 570 miles up. And it'll be all kind of new to me because the most I've seen of Brown County was from about 400 feet or 500 feet up off the side of one of the overlooks down there in the state park. We look forward to your lecture, Walter.
What I'd like to do is present a lecture that has several purposes in mind. First of all, I'd like to present some, I think, fairly interesting slides. I would like to look at a very specific part of environmental design called regional assessment, at least several aspects of it. And I'd also like to stimulate some interest in the probably more analytical and quantifiable part of environmental design. I thought, first of all, that I'd talk entirely on remote sensing, but decided that, first of all, we'd look at some slides covering various aspects of our environment. Yesterday, Michael dealt with primarily urban-type spaces, fairly small in scale, at least most of them. And what I'd like to do is turn to some more wide-open spaces. The second slide is Cache Valley in northern Utah. And I'd like to show primarily, at least to begin with, spaces that have not been impacted very highly or heavily by man. Although man's presence is very often felt, in certain instances it seems to blend in or be more part and character of our environment. This is again Cache Valley, and those are the Wellsville mountain range. The Lombardy poplars there happen to have been brought in by the Mormon settlers many years ago. They're not indigenous to that area, but I think they serve as a very nice environmental design element. Probably not planned as much as this slide is composed, but I think nevertheless they fit in that particular area. Much of our Earth has vast amounts of land which man hasn't done too much with. He hasn't made irreversible changes if you go along with the idea that building is relatively permanent. And we're using computers more and more in our profession and in many professions to deal with large amounts of information. And although these images aren't directly associated with a computer, many of the images that I'll be showing a little bit later will be directly from a computer or from parts of a computer. This particular area has been fairly heavily studied by Utah State University and various planning commissions, the slides that I have been showing. Most of the information and analyses have been done using computers there. Although many designers have a tendency to feel alienated when put up against a computer, I think there are some very good reasons for using it and to become familiar with it. These slides are another mountain range in northern Utah, the Wasatch Mountain Range. I've been hoping for snow for the past several weeks, so these make me even more hopeful that we'll get some eventually. These slides are taken at about a 10 or 15 minute drive from the main part of the populated area, the valley. And man's presence is felt, but in a way that is very much compatible, I think, with the environment. Ski paths are not what I would consider too much foreign to the land there. Can I get that one focused? Now we're switching to a little bit warmer climate down around Tucson, Arizona. Another type of environment that's very sensitive, the desert area. The previous slides were also a desert, but a cold desert as opposed to the Phoenix, Arizona hot type desert, or Tucson, excuse me, in this slide. But again, an area that's very sensitive for different reasons. Can I get that one focused? This is a forest to people in that particular area, the saguaro cactus. Now, as long as there aren't too many people here, and I guess even if there were greater numbers, I would like to have a very informal session, and if you have any comments or slides as I'm talking, feel free to interrupt me. The title of my lecture is Brown County State Park from 570 Miles Up, which implies, I think, several things. It implies remote sensing. It implies probably a different way to look at things. And the next few slides I'm going to take a look at parts of our environment from very close. Although we have a tendency not to look at it microscopically, we still look at it very close. From the 10th story of a building with other taller structures around. This again is Tucson, Arizona. Up into an airplane. Some very interesting things that most people can't discover standing on ground. Some very interesting patterns, some very interesting land uses. Yes, I hung out the window of an airplane and took them. It was actually on a trip out to Tucson. The images aren't quite as nice as if it would have been a run that was specifically designed for taking aerial photos. Just taking them out the window. It was Kodachrome, slide film, and I don't remember the speeds. Nope, just UV haze. This is the Midwest. You can tell many of the rivers, the farming country. Some that appear almost spacecraft-like, as is this one from the Skylab. Second and third manned images, or manned missions. This image is of Japan from the Skylab. You'll notice it gives us a whole different perspective of our environment. This one is Australia. Notice in this particular image the different landforms, the diversity that, unless we do traveling, we aren't really aware of. It's a whole different scale that we're dealing with. This one is the Phoenix, Arizona area. Quite different from the Australian view. This one's Cape Canaveral, Florida, Cape Kennedy. Notice the cloud formations from a long way from Earth. This one's a very populated part of the California coast. I believe around the San Francisco area. And another type of image. This is of the southwestern United States from Landsat. It's around the Texas and Oklahoma borders. Now this image, as opposed to the manned spacecraft, this image is technically a satellite, a computer image from a satellite. The satellite obviously doesn't drop film as we know it down to Earth, so it has to send It has to send images in the form of numbers that a computer can use. This happens to be a color composite to show some of the main land features. This image is from approximately 570 miles up from the Landsat. This is probably the second Landsat satellite. Now, I've mentioned remote sensing, and I think most of us are very familiar with remote sensing, although we aren't fully aware of it. Remote sensing means nothing more than the process of taking measurements from a distance. And we have a tendency, because of our nature and because of our physical makeup, to use electromagnetic energy, light. And some of the tools that we use for remote sensing are our eyes, our cameras, a multispectral scanner from which the Landsat images are taken, and I'll go into that in a little bit, and other types of apparatus. So it's something we're very familiar with, although when we put words, long names with it, it sometimes gets lost. We have a tendency to deal with only the visible spectrum, although the satellite images can also deal with infrared, near infrared, and now in the last Landsat, Landsat-C, launched, I believe, last March, they also deal with the thermal band. Now this diagram shows a satellite. My pointer I mentioned before that the satellite uses a multispectral scanner, and what that means is that there's a series of little mirrors, and it scans back and forth over the Earth's surface. And each pass it picks up certain information as the satellite is orbiting. And you'll notice that it's not quite north. The pattern that it takes is actually going more towards the southwest as opposed to north. It has a certain amount of overlap, which is information that you probably will forget very soon. But something I want you to remember is that the path, the scan that it takes is about 185 kilometers in width. And the images that I pointed out as Landsat and the ones coming up will be 185 kilometers in width. And that's what the satellite calls the scene. Now, the electromagnetic energy, or reflectance, sent back to the satellite, obviously there has to be a certain size piece of information that it can reflect. And the satellites are set up to reflect whatever is happening within a 1.1 acre area. So basically what happens is that the satellite looks at 1.1 acres, takes a measurement, a reading of that particular area, stores it until it sends it back down to Earth, and those are then turned into images. Now, the smallest unit that I'll be referring to is called a pixel, or a picture element, and that's the 1.1 acres. The Landsat-C has scanners that pick up blue, green, infrared, near infrared, and thermal bands. And it sends all that information back to Earth every 18 days. So Muncie has a photograph taken or an image taken every 18 days, as do most areas on Earth. The satellite, of course, is turned off over the water. There is also the second Landsat satellite, which is also still operating, and that takes images every 18 days, which means that we have images taken of virtually every place on Earth that we want, taken every 9 days. Tremendous amount of information in all 4 bands and now 5 bands with the last satellite. Now, it's always amazed me that these satellites have been operating and that nobody has been doing much with the information. I think in the design professions, the environmental design professions, it's very important that we start making use of this information, because data is something that has held up our analyses for years. Now here's another image. This is of the Mississippi River, and I don't remember for sure where. Somebody can read it up there. I guess that's around Washington, D.C. I'll take that back. So it must be a little different river. Yes?
What is the difference between the use of the same satellite and the high altitude planes? If the high altitude planes will use information very much in the locality, which would they use more?
The question. Okay. The question was the question was having to do with high altitude aerial photography. A tape like this, a scene, that's one of $200 for costs, but of information. Quite a few times before restricted as far as countries. That's fine in certain areas. Although this is too, but the countries seem much different. That's fine in certain areas. Although this is too, but the resolution. 1 acres on this particular slide, but if you, because of the scale difference, it looks as if it's one image. It has a particular symbol associated with it. Because of the scale difference, it looks as if it's one image. Again, this is another associated with it. Because of the scale difference, it looks as if it's one image. Again, this is another color composite to show, because of the scale difference, it looks as if it's one image. Again, this is another color composite to show certain features. It looks as if it's one image. Again, this is another color composite to show certain features. Again, this is another color composite to show certain features. Now, theoretically, each particular land cover, whether it be urban, whether it be crops, whether it be water, snow, would have a specific, an absolute value for it. And that was the reasoning when the Landsat satellites were first set up. They figured that if a cornfield had a certain reflectance value, every other cornfield would also have the same value. It was primarily associated with agriculture, the original satellites tapes were going to be used for agricultural reasons. They found, however, that because of different types of light, atmospheric conditions, because of differences in water or wetness of the site, many factors influenced what sort of reflectance values it has. It turns out that the circle area of downtown Indianapolis has the same reflectance value as corn. And this is shown true in research done at the Holcomb Research Institute at Butler. It's been shown at Purdue University, and it's also been shown at ISU. So there can be these funny little problems with reflectance values. These are some of the uses of remote sensing and satellite imagery. Crops as well as disease, snow cover. Snow cover has been very important in areas of the West where snow is, it provides much of the drinking water. I think it provides very interesting images also. We have forest cover mapping, as well as disease associated with forest, and also soils. Now, you should be able to notice certain patterns developing in these two images. The one on the right is a satellite image, and the one on the left has been transferred into a different set of symbols. Each particular plus or X stands for a certain reflectance value or a certain ground cover, land cover on the right image. What I'll be doing in the slides coming up is showing images that have been transferred in much the same way. In other words, there's a raw satellite image that's transferred into certain symbols that we can use and manipulate with the computer. Sound need to be focused a little bit? This image is kind of interesting. Again, it's a Landsat image. This is the Salton Sea, and this is the Mexico-California border. And I think it's very interesting to note that even country boundaries can be shown. Obviously, because of the difference in agriculture. This whole area is irrigated.
Below the border is marijuana, right?
Right. That's why there's a different color. Large areas of it. Okay, this one should be familiar, isn't it? This is, I believe, the southwest portion of Indiana. This one should be more familiar. See Muncie? This is the St. Mary's Reservoir in Ohio, and this should be Prairie Creek, so I guess that puts Muncie in probably around this area. Now you'll notice this just peeking through the clouds. Notice this body of water. What is this big body? Here you'll notice it again. You notice the difference in the cloud formations. Now, if you're buying information like this, it's of great concern to you whether it's covered with clouds, like the one portion of this scene. Through the Eros data center, you can take a look at a tape in the form of an image like this before you purchase it. So, again, computers are very quickly making images to see where the clouds are, and it wouldn't do a person much good to buy one that's covered with clouds. This, in a very poor slide, and I apologize for it, but there'll be a better one coming up, is Brown County State Park from 570 miles up. You'll notice down in this corner the Ohio River, and this is part of the Monroe Reservoir, which puts Brown County State Park in that general area. Now again, notice the clouds. This is a general map, everyone can tell. But I wanted to point out the relationship between Brown County and Indianapolis, because an awful lot of traffic goes through Brown County on the way to other places. People stop by, take a look at what's going on. And the next couple of images are of Brown County, the famous covered bridge. Well, it seems there are a lot of covered bridges around this area. As I mentioned, one of the primary uses for the park is just driving through and looking. It's incredible how many people drive through and don't even get out of their car, which is unfortunate. This is one of the major bodies of water, Lake Ogle, which I'll be pointing out. It's man-made. Now here's some regular aerial photography from several miles up. And you'll notice there's a body of water right here. That's Lake Ogle. I don't have a composite of the area, although that will be coming eventually. There's another major body of water, which is to the southeast of Ogle Lake. It's right here. That's Straw Lake. And this shows Nashville. Now pay particular attention to the type of terrain from the aerial photos, because you'll see that it's a very complex environment for many ways. not only in grade, orientation, but also in use. Now this is, I think, a little better image of Brown County State Park. Again, you'll notice the Ohio River and the Monroe Reservoir, which puts the park up in this area. Again, we're looking at 185 kilometers in width. Pardon? Those are clouds. Mm-hmm. And you'll notice that our particular study site is cloud-free. This is a scene that was purchased, and we used certain portions of it that we had geocorrected and various other processes. Could you focus that one a little bit? Now again, I want to point out clouds and emphasize that they can really make a lot of difference in the imagery, as this and the next slide should point out.
Well,
Yes.
these views of Indiana, where are they available?
Which views?
The ones-
The aerial photography?
Yes.
That was flown by the State Highway Department.
And they would have to hold the state.
Yes.
How about the Landsat?
Landsat has the whole state every 9 days since.
We have a set here.
7 or 8.
In our college.
The images that I have been showing you, the Landsat images, except for Brown County, are property of the Geography Department, so they're property of the university. They can be ordered.
They're accessible to us.
Right. Slides of the imagery, as far as just a visual slide, is relatively inexpensive from Aeros. The Aeros Data Center at about, I believe, $1 to $1.50 per slide for whatever area. You can pick out a county, you can pick out a state, you can pick out a region, whatever you'd like. If you wanted all of the information from all of the bands, now that would be, the slide would be a color composite. If you wanted all of the information, you would have to access that information by computer. And that should be at $200 for 185 kilometers. This is a base map composite of the study site from USGS Maps. Yes?
Are we reading those things, ridges? Am I reading that correctly?
Right, ridges and valleys.
But the light on the ridges.
Yes. Now some of the data that I show will be a little more evident. Now this looks like Greek or whatever, but it's an image from the satellite that's been converted by a computer. And each of those symbols stands for a certain cover, a certain land use. Now, remember we looked at Lake Ogle, which was very elongated, and Lake Straw. And these are two of the major water bodies. This happens to be part of the classification process of the satellite information. Each one of the symbols stands for 2.5 acres instead of 1.1 acres in this particular study site. Now this one shows marshy areas within the state park study site. This shows some grassland areas. Now the darker symbols are 100%, and there should be 4 symbols there: 25, 0 to 25%, 25 to 50, on up to 100% of a particular ground cover. We could take it at, say, 5% increments, 1% increments, 10% increments, whatever we'd like. And here's the forest type, which hasn't been fully classified. Again, it's an ongoing process right now. A forest cover that is very dark in relation to the other forest types. Now you'll notice some of the ridges and valleys showing some of the patterns, and a lot of it's pattern recognition, as much of geography is, looking at different patterns. Now here's another type of data. This has been gathered in a more traditional way, hand-gathered, and through a very tedious process, which most of the graduate students in LA are familiar with or will be familiar with, and hopefully from other disciplines very soon. This has been coded by hand off of USGS maps and put into the computer. And we can display the map output relatively easily and inexpensively. Now the darker symbol here, if you look at it, we have it on a gray value, so it's visually readable. The darker areas are the highest elevations within the park, and the ridge lines become fairly prominent from a distance here. This shows one of the overlooks and some of the change in elevation that's possible within the park. Pardon? Brown County State Park. The remainder of the slides will be at Brown County State Park. This particular slide should be percent of slopes. And we should have another slide, and again you can pick out the ridge lines, and this is orientation of the slope. Now it turns out that these three pieces of data were gathered and put into the computer as one piece of information. We took 4 corner elevations of a particular 2.5 acre cell, and the computer separated it into percent of slope, average elevation, and orientation or slope, orientation of slope. This one I guess is in slope, or percentage of slope, slope in degrees. And this shows some of the diversity in slopes within the park. This piece of data is water by types. And again, you'll notice Lake Ogle, which serves as a reference, that's a straw lake. And these are different types of streams. So they're valleys. And
what's the difference in the tone indicated there? Dark,
that one was arbitrary, depending on the type of water feature. The others were based on percentages, more percent, darker values. Again, this is a slide of the lake, and showing that it is man-made. And I believe the last piece of data we'll be looking at is circulation. This shows the main roads through the park, and as well as the secondary roads. Most of the roads are in very good shape, even some of the secondary roads or horse trails or other types of circulation. And this we have as soil types, finding foundations, maybe locating roads. It's a very interesting architecture as well as natural features within the park. Now, we have a lot of data, and many people can say, well, you have all of the data, and now what do you do with it? And primarily what we've been doing with it is using it as a planning tool. In other words, use it to find areas that would be either suitable or unsuitable for a particular type of development, find areas that would be sensitive to development. This particular slide and the one before it, and I believe after it, show one of the campgrounds. After visiting many campgrounds in the western part of the United States, it's actually quite strange. Very nice deer there, though, if you can pick out deer in this slide again. But I think the location of activities like this should be more than arbitrary. And some that happen in the park right now, I think, are quite arbitrary. The information can be used to find overlooks, to find the best place for the roads, to find and maintain certain areas that can be used as open spaces, as meeting places, nodes. To protect certain features. Maybe to help with signage. And locating large structures, smaller structures. I think that the Brown County State Park is a very valuable resource for those of us in Indiana, especially if you're used to a diversity in terrain and country. For me, anyway, it's very good for me mentally to spend time in this area. And I think that we as designers owe it to ourselves as well as to other people that we design for to make very rational and very responsive decisions. This is the Nature Center. Some more of the architecture of that area. And closing with this slide as to show some of the very dense vegetation that's present there. I would like to offer the research that we've been doing within our department to the college as well as to the university, with hopes that it can be used as a tool for our design classes, for our planning classes, and hopefully expanded through use. I would hope that over the next several years we can develop a very comprehensive database, especially a computer database for that particular area, which will set a precedence for this type of analysis in Indiana. There are several computer databases around the state right now, I believe 2, but they aren't being used for anything. And I think to show different ways that this could be used and tie into the design professions, I think it would be a very good thing for the departments, college, and university to maybe be forerunners in this type of analysis. Thank you.